In number 22, we have y is greater than x minus 2, which is already in the form of y equals mx plus b, where your slope m is 1 and it crosses the y-axis at the point 0, negative 2. Okay, so we first plot the line y equals mx plus b by going to the point negative 2, y-axis, and counting up 1, over 1, and drawing a line. But we have to decide if that line is going to be a solid line or a dashed line. And since we are looking at the operator greater than instead of greater than or equal to, then we need a dashed line. If it had had an equal component, we would have had a solid line. Now the question is, how do we graph it, shade it? Do we shade above the line or below the line? And since we are dealing with a greater than symbol, y is greater than the line, think of it that way, then we graph above the line. Now let's take a look at chapter 19. We'll begin with problem number 23 on page 6. It says rewrite without exponents, and the problem is 49 to the 3/2 power. So when you convert that, what you're doing is you're converting it to a radical expression where the 49 is the radicand. The denominator of the exponent is your index, and the numerator of your exponent is your exponent again. Now I'm putting this outside of the radicand. You could also accurately have it in there, but it doesn't help us to have it in there, and I'll show you why. So now we have the square root of 49, all of that cubed. Well, we know that the square root of 49 is 7, so we can reduce the square root of 49 to 7, and now we have 7 cubed. And then all we have to do is cube the 7, and that gives us 343. In number 24, we are simplifying the cube root of 54x to the 8th. That is going to be the same as the cube root of 54 times the cube root of x to the 8th. Now, you may be able to do this in your head, but let's go through it. The cube root of 54, to find that, let's do a factoring tree and bring it down to its fundamental components, to its prime number factors. So here we have 3, 3, and 3. Let's circle them, and 2. So you're circling everything prime that's at the bottom of your tree. And so you have 54 is 2 times 3 cubed. So we have the cube root of 2 times 3 cubed, and the cube root of x to the 8th, which we'll deal with in a minute. So the cube root of 3 cubed is 3, and we're left with, don't forget your index, the cube root of 2. Now let's look at the cube root of x to the 8th. Okay, I'm going to show you a shortcut for this. You take the exponent 8 and you divide it by the index 3, and 3 goes into 8 2 times with a remainder of 2. So what you do with that is you pull out the x from the radical and you give it the first 2, how many times it goes into 8, and what you're left with under the radical is x squared, which is the remainder. So now we can combine all of that, 3x squared times the cube root of 2x squared. In number 25, we have to simplify 3 terms which are added or subtracted, and they are not like terms. So our goal is to convert them into like terms. let's see how we can do this. I can look at 128, and if I divide it by 2, I get 64, which is a perfect square. So I'm not going to worry about my factoring tree for that one. Same with 18. It's 9 times 2, and 9 is a perfect square. And 32 is 16 times 2. I'm looking for perfect squares because I'm taking the square root. If I were taking the cube root, I'd look for perfect cubes. So let's rewrite this to show our perfect squares. 8 squared is 64. 3 squared is 9. And 4 squared is 16. Okay, now we pull out our squares. The square root of 8 squared is 8, so we have 2 times 8 square root of 2 minus 3 square root of 2 plus 4, our 4 on the outside, and then the one we pull out, square root of 2. Now we have like terms, so let's multiply 16 square root of 2 minus 3 square root of 2 plus 16 square root of 2. 16 minus 3 is 13. 13 plus 16 is 29. And that's our answer. When we multiply radicals, in this case, let's first distribute. We're going to distribute the square root of 5 to the 4, and then again to the 2 square root of 5. So we have, I'm going to put my number on the outside of the radical, 4 square root of 5 minus, and then 2 on the outside, and then we have square root of 5 times square root of 5, which is square root of 5 squared. Now the first term is already simplified. The second term, we can pull out the square root of 5 squared, which is 5. So that gives us 4 square root of 5 minus 10, and conventionally you would write the number without the radical first and then the radical. In number 27, keep in mind that a denominator cannot have a radical in it for the expression to be simplified. So this problem could ask you to simplify. In this case, it's giving you a hint. It says rationalize the denominator. And in order to rationalize the denominator, when the denominator is a complex expression, you need to multiply it by its complex conjugate in order to clear the radicals from the denominator. It is okay to have radicals in the numerator. The complex conjugate of 6 minus square root of 10 is 6 plus square root of 10. I want to remind you of a formula. The difference of squares is the same as adding the roots and then subtracting the roots. Similarly, if you have something that's added, a binomial with addition, and the same numbers are subtracted in the same order, then that's the same thing as the difference of squares. Now, when you have 6 minus square root of 10 in the denominator times 6 plus square root of 10, then you can use this formula, a plus b, a minus b, and it can be in either order. Then that's going to be equal to 6 squared minus square root of 10 squared. Alright, and the square root of 10 squared, actually in this case, let's write it under the radical. The square root of anything squared is itself, so we have 6 squared minus 10, and that gives us 26. So our rationalized denominator is 26, but our numerator is 9 times 6 plus square root of 10. So back to this expression, we're going to multiply our numerators over our denominator, which is 26. 9 times 6 is 54. And since there isn't a common factor in all three, 54, 9, and 26, then we can leave it like this. Or you could break it up and still have the same answer, same value. But if you do this, then you need to simplify the first term so that you would have 2 goes into 26 13 times and 2 goes into 54 27 times. So you would have 27 thirteenths plus 9 times the square root of 10 over 26. It's easier to just leave it in this format so that you don't have to take the extra step.